Okay, we're going to do a development. So we're going to create a 3D or 2D outline of this 3D shape. Now this comes from the 2017 HSC. Notice that it's I think it's worth 4 marks. You see that on the other page, that it's worth 4 marks. So you've only got about 8 or 9 minutes to do it. It's not a long time. Orthogonal and pictorial drawings of a sheet metal electrical cable cover are given below. So there's the pictorial. Notice it's not to scale, and here's the orthogonal. So what I would do first up is just make sure that you can identify the top and the bottom view, the top and the front views. So there's my viewing plane. That'll be the top view, and this will be the front. Alright, the next thing to do with drawing like this, because you've got to do several shapes, is to label it so that you can help yourself. Now, generally when you label your one side in numbers, so that might be X, make that 1, make that, well, see we've got X, we'll do it on the pictorial, X1, 2, and 3, and then here we're going to go Y, A, B, and C. So we're looking from the top, we're going to see 1 and 2 here, or 2 and 1. Here we'll see 3. Here we'll see C. And here we'll see A and B, looking from the top. From the front view, we're going to see X and Y at the top there. Just helps you orientate yourself. So we're going to also see 2 and 1 and X. They're all going to, I should say 1. That's not correct. It's just 1 and X, not 2. So 1 and X are going to be at the top. 2 and 3 will be down the bottom here. And down the bottom there will be B and C. And here we'll have Y and A. Okay, does that make sense? Alright, so we've labelled them, which is important, you'll see why. Now on the next page we're given the actual question that we're supposed to answer. I'll turn it over for you to see. And it says, draw a half development, so you don't have to do the whole shape, of the electrical cable cover. Use the center line below to position the document. Alright, there's 4 marks. Now I'm going to go back over here because I know I've done this. It's going to fit in. I'm going to do it all on the one page because otherwise you're not going to see what I'm going to do. It's going to be a pain in the neck. So let's just draw our line down here. That's the line that we're going to run it on. And over here they did X at the start. So we're going to start with our X over here. So that's X. Alright, now the next thing to do with a drawing like this is to identify what all of the true lengths are. So just write them out. So looking down, straight down on it, that's going to be a true length. This is a true length because it's parallel to that, and they're also parallel to the vertical viewing plane. That's going to be a true length. So that's a true length here on the front view. That's going to be a true length. We're going to have true lengths of all of these flaps. See those ones? They'll all be true lengths. So looking from the top, these things here are parallel to our viewing plane. So that's a true length, that's a true length. Now, be careful here because looking vertically down, there's 2 lines that we see. This one, which is a true length, but that one is not. So A1 is not. So be careful of that. That's a true length. 1, 3 is, or 2, 3 is a true length, and BC is a true length. So I think that just about does our, or there's one more true length. This seam that you see over here, XY, there it is there. When viewed from the side, that seam will be parallel to this viewing plane. See it? Parallel? That is a true length. So XY is a true length over here. Okay, so they're true lengths. It's good having the pictorial view here. True lengths, true length, true length, and that's a true length. Now from the top this is also a true length, and that's a true length. Okay, so let's start doing our drawing. Now first thing to realize, I suppose, is that we're going to start with X because they've given us X. So here's X, and we know X to 1 is a true length. So what's that distance? Well, there it is. We'll just measure it, I suppose. Look, another quick way of doing this is to grab yourself a set of dividers. I hope I didn't just, yeah, anyway. I should keep that in focus. Alright, so just to, I'm not sure, this might have gone off the page when I was talking to you before. You may not have seen it. So the true lengths, I've written them all here. They're all true lengths, either viewed from the top or the front view. There's lots of true lengths. This is not a true length. That's probably the main thing that we don't have that's not a true length. So we're going to have to establish that. Alright, so we're starting with x. X and y is a true length. So let's just put x and y down here. So what's y going to be? Well, x and y we can measure straight off this using a compass, or you can measure it if you want to measure it. I find it easier just using a compass. So there's y. X is here, and there's y. So we've got that one. That's our starting point. Now the next thing that we have to draw, and this is going to be a right angle, so that'll be a right angle, and that'll be a right angle. So we know that we're going to have right angles coming off here. I'm just going to roughly do them. Right angles from there, and we're going to have a right angle from here. Remember, we've only got about 4 minutes or so to, or no more than that, about 8 minutes to do this tops. Alright, so x to 1, that distance there, that distance is a true length. So let's just quickly measure it. It looks like it's about 8 millimeters. So x to 1, 8 millimeters. Here we go, that's 0.1. So x to 1 is 8 millimeters. There's our right angle. Good. Now, to generate the rest of this, x to y is also a true length looking vertically down. So we can do that. X to y, we'll measure it over here. It's now going to be 29, almost 30 millimeters. Let's just say it's 30 millimeters. I like even numbers, 30 millimeters. That's x and y. Now we also know that's a right angle. That's a right angle and that's a right angle. So there's our two right angles. And given the fact that we know this position and that position, we can just draw a line between the two of them, and we've actually created our first shape. Right. So that point there next to y, that one is down here is A. That's it there, point A. That one there. So we've just created this shape. That's a right angle. That's a right angle. We've created that shape. Now that's great. We've got this shape here, if you like. We've just organized that. We know what that looks like. The next shape is going to be this side here that we need to sort out. Now to do that, we need to figure out where these points are. Now point 2 is going to be, that's a true length. There it is there. So let's get our compass out and get this thing down to that distance, because we're going to create a semicircle or an arc that lies with point 2 on it somewhere. Now 2.2 comes off from point 1, so it's off from point 1 here, and there's an arc. So point 2, I don't know if you can see that, will lie somewhere on that arc. We're not sure where really yet. We don't quite know. That's that point. Now to identify exactly where it is, we need another line to arrive at that point. Now we need some other intersecting arc. So if we knew, for example, the distance from A to 2, the true length of A to 2, we could do that, scribe an arc and locate exactly where that point is. So we're not actually given that point, so we're going to figure it out, what that point is. Okay. Well, the other way of doing it is we can go from, to determine what this point is here, B. It doesn't really matter. Either way, it's going to work for us. Alright. So let's go, we'll create an imaginary line from B to 1. Why am I doing this? I want to work out where, well, I can do it the other way. We spoke about 2. Let's go from A to 2. So I'm going to draw a line like that from A to 2. I want to work out that true length. Then I can take an arc from A and I can scribe it and I can find point 2. I know where A is. It's 2 somewhere along there. I need that true length. Alright, so I've gone from A to 2 here. Well, what's that look like over here? Well, looking straight down, vertically down, or down here, now looking straight down here now, it's not at right angles to any of our viewing planes, so I've got to turn it at right angles. So I'm going to go from A to 2. So let me spin it about this point here. I'll wind the compass out. There's point A. Okay. So I've taken an arc, spun this whole thing around, and I want to get it till it's parallel. There we go. Parallel with that viewing plane. And at that point here, I've taken this whole face and I've turned it around so that it's now parallel to the viewing plane. And I want to be able to now determine, drop this line down here, because remember A is up high, it's sitting on this plane here. Drop it down. There we go, straight line. We're going from A to 2. Okay, so point 2 is down here, and A will lie along this plane somewhere there, at that intersection there. Because as we spin the object around, it doesn't go up and down here, it stays on this same plane, but it's actually going to be rotating out to hit that point. Yeah, we just spun it around here off that axis, dropped it down to that plane, and that's where point A will be if it was exactly horizontal to the plane, the viewing plane. So now I've got to go from 2 to A. So from 2 to A is this distance here. 2 to A. There it is. 2 to A. Now that particular bit of information is very, very useful for us, because as you're going to see, it's going to let us be able to work out exactly where point 2 is. There it is. Now we've got that arc distance. So if I place this on point A, there it is there, and I scribe an arc, and wherever it intersects, right there, the arc I did for 2, see that's the 2 arc, that point of intersection over there, that's exactly where point 2 is. And the way we did that was we knew that point 2 was going to lie at the intersection of this standard length, or this length here, which is a true length. So we scribed an arc of that true length. And then we also knew that if we knew the distance from A to 2, the true length of A to 2, we could take a compass arc from A to 2, with that distance from point A, and wherever they intersected would be point 2. And there it is there. Okay. Now the next point that we need to figure out won't be too bad for us. We've got this point. We now need, we've got all of this shape here, and we've got that point. We know where it is. We now need to find out where point B is. Point B. Now, we do know this distance. It's a true length. There it is there. So let's get our compass going and scribe an arc, which is that distance around the place. So there it is there. From A to B is this length here. Does that make sense? Now, point B is somewhere along that arc. I don't know exactly where, but it's somewhere along this arc. To find out where it is, I need to be able to scribe an arc from point 2 to B. Now, do I have that as a true length? Yes, I do. And there it is there. Point 2 to B. To B or not to B? Whether to scribe an arc is better or not to. So now I'm going to wind my compass out. I'm trying to do this to make it look easy, but I'm probably not succeeding to show you. But I'm scribing my compass out to get that true length, because that's the true length at the bottom. And then I go from point 2 here which I've located, and provided I've got this right, everything will be cool. And I scribe the arc, and wherever those two arcs intersect is point B. There. Now we're almost home and hosed. I'm going to draw a little bit of a longer line. I'll tell you why in a minute. And here's point B here, and let's go to point 2. So that's a true shape of section of this shape here. There it is there. Now, next part is quite easy, because these tabs that sit out there like that, they're actually true shapes that we can see looking down from the top. So we know all of their distances, and we also know that they are at right angles. Yeah, right angles to these lines. So AB, and 1, 2, they're at right angles. So all we need to do is extend these lines out, because we know they're at right angles to these lines. Measure the distance, which is a true length here, which is going to be, let's say, 8 millimeters. 8 millimeters. Make our mark and draw the line across like that. And it isn't perfect, but it shows that we know what we're doing. And these points here are, that's point C, and that is point 3. Now we've actually got ourselves halfway. That's a half development. From here to here to here. We're halfway. That's called a half development. And it's all finished. All done. Okay. So the main thing, just to go back over the points again, very important. Firstly, label what you know as true lengths on each of the drawings. Secondly, label all the points, and usually do numbers on one side and letters on another. Start where you're told to start, and start working your way across from point to point. If you find yourself you have a shape like this shape that we just showed over here, which doesn't allow you to be able to locate these other points, then you're going to need to draw a diagonal line across and work out the true length of that diagonal line, and use that diagonal line as a way of triangulating between two arcs to find a point of intersection where you can locate that point. And once you've done that, you split the shape up into two triangles like we've done here. They're the two triangles. It's easy to find all the other points. Okay.